Lesson 135, bar graphs. For the next few lessons, we are going to look in depth at the 3 different types of graphs that we learned about briefly in the introduction. And today we're going to start with bar graphs. So in the introduction lesson, we learned that bar graphs are used for comparison. So they're really just a visual representation or a visual way to compare data in your data set. So here I have a very simple basic bar graph. It's for class size, probably for high school or college, university, where you get to choose, students get to choose which subjects to take at certain times. And what you can do is you can look at this bar graph and you can just at a glance be really aware that art seems to be the very most popular class to join, whereas history seems to be much less popular. So it's a visual representation, but we've still got pretty exact numbers. And bar graphs can be used to compare more than one thing at a time. So what we have here is a bar graph for participation in camp activities. So we've got all our activities down at the bottom here. We've got the number of campers over on the side here. And you'll notice we have 2 bars for each of the activities. So where we have to look is up here at what is called the key. Now the key to this bar graph tells us what each color or what each bar of each color represents. So if we look at the tennis category, for instance, it looks like more girls are interested in participating in tennis than boys are. So it's a little bit more popular with the girls. Swimming seems to be equally popular, right? Equal bars, equal popularity, and going from there. So it gives us a little bit of an added layer of information. The maker of this bar graph could have just put it all together and we could have seen what was the most popular. But what this does is it breaks it down for us and lets us know by gender what is more popular. And I suppose if you wanted to know how popular tennis was, what you could do is you could say, well, there are 30 girls who participated in tennis. There are 25 boys. You simply add those up and then you've got your total number of participants. So you can get all of the information that you need from this double bar graph. And your number of bars can increase depending on the type of data you have, the information that you need to show. Here we have a population graph by country. So we've got countries down here. We've got a key up here telling us what all the colors mean. So for each bar, for blue, it represents the population in 1980 in that country. And you'll notice also that over on the side here, the population is telling us in millions. It's not just like 50 or 60 people live in each country. A lot more than that do. So increasing your number of bars depending on your type of data and what you need to show in the graph. Then just a few terminology things. The first thing we need to know is the word scale. A scale is just the name for what I'm highlighting right now. The numbers on the vertical axis or the side, you can think, that show what your bars mean. So for this graph, it goes from 0 to 25. So we know that the number of students taking each class is somewhere in between 0 and 25, and then our individual bars line up with certain points on that scale, which gives you the information you need to know. The next thing that we need to know is the word interval. An interval is really just the space, or you can think about it like kind of like a jump between the numbers on the scale. So this particular scale goes up by 5s at a time, right? 0 to 5, 5 to 10, 10 to 15. Jumping up by 5s, just the space or the difference between the numbers on the scale. And it's really important that you increase by the same interval every time in order for your graph to be accurate. So you wouldn't go from 0 to 5 and then suddenly jump to 6 and then suddenly jump to 24 on your next line. You want to make sure that you're going up by even intervals. And something that you may see and you will see in your textbook for sure today is that sometimes your data doesn't necessarily need to start down at 0. So we have here graph A and graph B. Let's start by looking at graph A. It's describing the births in 1997, and our scale on the side goes from 0 to 2 million. Okay, so people born in a certain place, I'm not exactly sure where, this graph didn't give us that information, in millions, it looks like about 2 million of them were male and then just under 2 million were female. All right, but since there's no bars that need to go lower down here, it's not necessarily necessary to start your scale at 0. What you can do is just draw a little squiggly line. It's kind of like a broken line there, and then start your graph a little bit higher up. Because this graph doesn't have, or your data set doesn't have any numbers that are lower than 1.7 million, you don't need to start your graph at 0. So you can just draw a squiggly line, start it at 1.7 million, jump to 1.8 million, 1.9 million, and then 2 million. And then that actually gives a little bit more of an accurate picture of what's happening here, right? We can see that the space here seems a little bit bigger than it did on graph A. So it gives you your graph a little bit of a different shape and perhaps can make your graph a little bit more accurate. So just be aware that that is something that can happen as well. And then the last thing for today is that you need to know that you have to use the graphs on page 290 of your textbook to answer the questions. So don't just look at the questions which are on page 291 and think, where's the graph for that? It's on the previous page. So make sure that you're looking there for your information. And then you should be good to go.